All right, we are going to get started. And we're talking about lesson 7.5 today, factoring a quadratic trinomial. So those things that we did last week and early this week will really pay off today if you understand factoring numbers and finding numbers that add to a certain value and multiply to a certain value. This is really what that is leading up to. Also, being able to factor out greatest common factors is a big part of factoring um, quadratic expressions, specifically quadratic trinomials. All right. So if we start kind of with what we did last week, we were looking at pairs and trying to find two numbers that multiply to the top and add to the bottom. So either use the chat or unmute yourself and let me know what are two numbers that multiply to 12 and add to 7. And if you don't know, remember, you can always look at the factor pairs, 12, 1. Oh, I'm sorry. I always do it 1 and 12. Yeah, there we go. Perfect. Perfect. 4 and 3. And it doesn't matter which side you put the 4 on and which side you put the 3 on. You could put the 3 on the left and the 4 on the right. It doesn't matter because both adding and multiplying, it doesn't matter what order you do it in. So if you did write out the factored pairs, you would get down to 3 and 4, and that would be your pair. All right, two numbers that multiply to 9 and add to -6. So here the negative is kind of the big deal. So we have to multiply to a positive value and add to a negative value. So that means both of our numbers have to be negative. Perfect, perfect, yeah. In this case, it's -3 and -3. The same number, so obviously it doesn't matter which side we write it on. One of them on one side, one of them on the other. Multiply to 18 and add to -9. Again, both are going to have to be negative. Again, if we need to. All right, someone's got it in the chat. Yes, excellent. -6, whoops, -6, there we go, and -3. Last, and again, this one you could write out the factored pairs. Now, remember, they have to add to -9. That doesn't mean they have to have a factor of -9, so just be careful on that. Multiply to 16, add to -8. Excellent. -4 and -4. Perfect. All right. So how is this going to help us with factoring polynomials? Well, I'm glad you asked. So if we consider the binomial and we multiply x plus 2 and x plus 3 using FOIL or the box, and you can verify this if you would like, we get x squared plus 5x plus 6. So if we wanted to write x squared plus 5x plus 6 in factored form, what we would need to do is find two numbers that multiply to 6 and add to 5. And what two numbers multiply to 6 and add to 5? Yeah, 3 and 2, perfect. Which means the factored form is x plus 3 times x plus 2, or that form that we had right up here. Again, the order doesn't matter. You could have x plus 2 times x plus 3 like we have in the before the problem there, or x plus 3 times x plus 2 like we have, like I wrote down here in blue, but that's the factored form. So we talk about kind of the general form of x squared plus bx plus c. And we looked at when b and c are both positive in that last example. Here, we're going to have b negative and c positive. So we're going to find two numbers that multiply to 18 and add to -11. Again, they multiply to a positive, add to a negative. So both numbers are going to be negative. And if you ever get stuck, go back to the pairs, -1, -18. Add them up. Do you get -11? -2, -9. Add them up. Do you get -11? Oh, there I do. So you want to be careful because our numbers have to multiply to positive 18 and add to -11. So I always look for numbers that multiply to the 18 first. Because there are a lot of numbers that add to -11 but don't multiply to 18. There aren't nearly as many numbers that multiply to 18 that don't add to -11. As a matter of fact, there's only one other pair. It would have been -3 and -6. Whereas numbers that add to -11, there are a bunch. And if they're both negative, -1, -10, -2, -9, -3, -8, and all, I mean, there's a bunch. So I always start with the ones that multiply to the top value or up to our value of C. And then check which of those add to our value for B or our bottom number there. All right. Another one here where b is negative, our middle number is negative. We're finding two numbers that multiply to positive 15 and add to negative 8. Again, both have to be negative. All right. Yeah, there we go. There we go. Negative 5 and negative 3. Again, order does not matter. You could put the x minus 3 first, or the x minus 5 first. It doesn't matter. The great thing about these factoring problems, we can always check our answer by using FOIL or the box method to multiply these out. And what you're going to find is, if I really quickly just check this one, x minus 5, I'll use the box method. X times x is x squared. X times minus 5 is negative 5x. Negative 3 times x is minus 3x. And this is plus 15. So you see our two numbers, negative 5 and negative 3, multiply to 15. And if I combine my like terms, negative 5 and negative 3 add to negative 8. So that idea comes right from either the box or the FOIL method. That's why this approach works so well. All right, a couple for you to try on your own. So remember, we want to multiply to the last number. We want to add to the middle number. I'll give you a couple minutes, and then we'll take a look at solutions for those two. All right, so for these, again, if you use the X method, they need to multiply to 36, add to positive 13, I get 9 and 4. And multiply to 28, add to 11, 4 and 7. All right. Any questions so far? Again, if you have a question, don't be afraid to put it in the chat, or don't, you can certainly unmute yourself and say, oh, Mr. Gingrich, wait a minute. All right. Now we're going to look at what happens when C is negative. So here, the idea is still the same. We want to multiply to -6 and add to +5. So now we know that one number has to be positive, the other one has to be negative. And in this case, because it has to add to a positive value, our larger number has to be positive. So these might just be easier to list out the factors, because the mistake I see most often on a problem like this is students think about 6, multiplying to 6 and adding to 5, and forget about the sign. So they'll say, oh, it's -2 and 3, but that adds to +1. That's not the right factor pair. -1 plus 6, that adds to +5. All right, so again, we're looking for two numbers that multiply to -14 and add to -5. And I think by far these with where C is negative are the most difficult. So let's see. In this case, the larger factor has to be negative. So we're going to have one positive and one negative value. So 1 and -14. That adds to -13. That's not right. 2 and -7. That adds to -5. That is right. And so we always want to write the factored form. Our answer isn't the x part here, but our answer is the two binomials that multiply to give us our trinomial, our quadratic function or expression. Two numbers that multiply to -16, add to +6. So now the larger number is going to be the positive factor, but we're still, because it multiplies to a negative, we're still going to have one positive and one negative. So -1 and 16. No, that's not it. One of the reasons I like listing out the factors and starting with either 1 or -1 and the number is I'm sure not to miss anything if I start at 1 and work my way down. Here, these add to +6. All right. If you remember from multiplying binomials, we had this thing that was called a difference of two squares, where we had something squared minus something else squared. We can also have that working backward. So now we're given, if we're given an expression with two terms and subtraction in between, our answer is going to be the same value. So a squared minus b squared factors into a plus b, a minus b. One way to think about it, if you really like that x method, this is x squared plus 0x minus 9. And that plus looks like a 4, and I don't want that. I want it to look like a plus. So what we're looking for, if we only have two terms, we're looking for two numbers in this case that multiply to -9 and add to 0. The only way that can happen is if our two numbers are exactly opposites. That's how it's going to add to 0. So multiply to 9 and add -9 and add to 0. So you can see we have the same expression, just a different sign in between. All right, now this is even more difficult, and we really can't use the x method if we have a number in front of the x squared. So here we would have to recognize there are only two terms. So we're just going to get a difference of squares. So another way to approach this now is what number times itself gives me 4. Again, just shout it out or put it in the chat if you would. What number times itself gives us 4 as an answer? Yeah, perfect, 2. So that means we're going to have 2x plus something and 2x minus something. And that something, it comes from the minus 81 here. What number times itself is 81? All right, a little quicker on the draw that time. Yeah, 9. So it's going to be x plus 9 and x minus 9. And if we wanted to double check, we could multiply it out and verify that when I multiply this out, I get 4x squared minus 81. Again, you could use either the box method or the FOIL method. Should get the same answer either way. All right, a couple for you to try. Again, I'll give you just a couple of minutes, and then we'll look at answers and go move on from there. right. So again, if the x squared doesn't have a number in front of it, you could use the x method. They have to multiply to negative 36, and then you have to remember they have to add to 0, because this is like x squared plus 0x minus 36. It just means we have opposite values. If there is a number in front of the x squared, we need to be a little bit, the x method doesn't work quite right. There is a way to do the x method, and actually we'll talk about that next week when we have a number in front of the x squared. It's just a little bit more involved. The easiest way, if you only have two terms, what number times itself is 9? I think it's 3. And then what number times itself would give you negative 100? Or what number times itself is 100? And you get 10. You know one has to be positive, the other has to be negative. All right. So one other thing I want to look at or talk about, and we're going to make a table. So if I have this table, try this one more time. And I'm going to have my expression. Larger factor. Smaller factor. So if it is x squared plus bx plus c, if they're both added, my larger factor is positive and my smaller factor is positive. If it's x squared plus bx minus c, my larger factor is positive, my smaller factor is negative. If it's x squared minus bx minus c, goes negative, positive. And if it's x squared minus bx plus c, it goes negative, negative. So that little chart might be something helpful to have, jot down in your notes. Just to help you out as you're working through problems. Oh, it's in this form, so I've got to have one positive, one negative, or however you want to use that. All right. Any questions?